the result, the nodal analysis for our original case, natural flow, okay, natural flow of oil well, we get oil rate of 12,146 stock tank barrel per day. Okay, so this is the case where the water cut is 0. So for example, we already continuously produce this well and the water cut increases. Okay, the water cut increases. So now we go to the last case. So this is the second case. It's natural flow. It's easy. So let's say the story is like this. Now the water cut increases to 54. Okay, 54%. So we need to change the water cut in IPR section from 0 to 54. Click done. Okay. And let's say after the water cut increases, now the salinity increases as well. Okay, the salinity of the water. Previously, the salinity is only 23,000, but right now it's 180,000 ppm. Okay, and with this high salinity, we fear there will be problem. Yeah, because maybe the salt will deposit and will create scaling maybe inside our tubing. The salt will deposit and it will block the wellbore because the salinity is too high. Right now it's 180. Okay, 180,000 ppm. So to solve that, we will dilute. We will make the liquid diluted. Okay, so we will inject diluent inside our wellbore. But if you inject diluent to make the salinity smaller, lower, to make the fluid more dilute, okay, you inject water. But of course, if you inject water, then your flow rate will be decreased because now it is heavier. The fluid will be heavier, and now the well will work harder to push the flow. That's why, in addition to diluent injection, we will also install gas lift. Okay, so that the flow can continuously will continue. Okay, so in one thing we will inject diluent water to smaller down the salinity to avoid the salt precipitation. Okay, but at the same time we will also install gas lift to support the production. So now we click done. And now go to the option summary. Right now we are on the case 3. And now we change the artificial lift to diluent injection. Here, diluent injection. Okay. And that's for the method. The type is annular injection tubing production. Okay. So that's click done. And now we go to the PVT data. Here again, the salinity increases 180,000 ppm. And now we need to input diluent properties. Okay, the properties of our diluent. And the diluent type, we will use water. But now this water is with lower salinity. So it's fresher, more fresh than the reservoir fluid. The salinity is only 20,000 ppm. So 20,000 ppm, the diluent water will dilute the original water from the reservoir. Okay, again, this is to avoid salt precipitation that can block our pipe, that can block our tubing. So it's quite easy. we just need to provide diluent properties. Click done. All right. And the IPR will be the same. We just need to adjust the water cut to 54%. Okay. And click done. Now, because we install diluent injection, okay, there will be gas lift as well that we provide. So we need to, here, we add this section. Okay. And then the diluent depth is, diluent injection depth is at 9,000 feet. Okay. So that's the spot to inject the diluent water. And diluent injection rate, we start with 5,000 stock tank barrel per day. So click done. And we need to change this equipment data, downhole equipment. All right. So I think that's already good. Okay, cancel. So it's, let me check again. So tubing flow, and then producer, diluent injection. Oh, sorry. So here, annular injection, but plus gas lift. Yeah. And annular injection with gas lift. So now we will install gas lift as well. Click done. Let the system be ready now here. Okay, so now this is the spot of our diluent injection. And again, click this one. So the diluent injection depth is at 9,000 feet. Diluent injection rate 5,000 stock tank barrel per day. And the gas lift gas gravity, injected gas gravity, for example, 0.7. No H2S, no CO2, no nitrogen. The GLR, gas liquid ratio, for example, 50, gas lift depth is at 7,500. And later on, we will do optimization to get the best GLR and the best injection rate. So click done. Okay, and then here. So we have our injection gas lift injection depth here and diluent injection depth here. But again, we need to check downhole equipment. Okay, so far so good. There is no, oh, sorry, this one, casing inside diameter. Now we need to input casing inside diameter to calculate the annulus. So it's 6.4 and also 6.4 here. All right, so far so good. So click done. And we can check the summary. So there is error. Let's go back to downhole equipment. Oh, here, I forget to input the tubing outside diameter. So tubing OD is 4.8. Okay, so after providing the tubing outside diameter and casing inside diameter, Prosper will calculate the annulus. Click done and summary. This is summary in table and drawdown hole. So this is our well configuration. We have Christmas tree, tubing with inside diameter and outside diameter, and also the subsurface safety valve and tubing and injection point. Okay, and the casing as well. So click done, click done, click done. All right, now we are very ready to do the nodal analysis. So we go back to calculation, system IPR VLP, wellhead pressure 250 and water cut 54. And then total GOR is 800 and everything maintained as per default. And now we will create cases. to get the best GLR, gas liquid ratio, and the diluent rate. So open the drop-down menu. We will do sensitivity analysis for diluent, this one, salt diluent rate percent. So we will calculate the best ratio, the best percentage of the diluent. So it will be in range of 20% to 40%. So I will create 20, 25, 30, 35, and 40. Okay, and here we can click done, and then we can calculate. All right, so we have 5 cases of diluent percentage. This one for 20%, 25, 30, 35, and 40. And of course, if you increase the diluent rate, increase the diluent percentage, the flow rate will be smaller because now the fluid is heavier, okay? Heavier to be lifted. So the flow rate will be decreased. You can check the plot, system plot, plot all cases, done. So it's like this. You can maximize, all right? And go to replot here to get the original view. Click finish. Now, oh, by the way, you can check the sensitivity plot. So here, variables, get the liquid rate, click done here. So if you increase the diluent rate or increase the diluent rate percentage, your total liquid rate will decrease because now the fluid is heavier to be lifted. That's why we provide gas lift to make the fluid lighter. Okay, so click finish. Now in cases, we add GLR injected. This one, gas liquid ratio injected. And we have 10 cases from 0, 150, 300, 450, 600, 750, 900, 1050, 1200, and 1500. Click finish, click done. And then now we have 50 cases, right? But that's okay, Prosper is very fast. So click calculate. Let's see, now we combine gas lift injection with diluent rate injection. So we will dissolve the salt to make the fluid more dilute, but at the same time we inject gas lift to make the fluid lighter. Okay, so click OK. And now let's plot, system plot, plot all cases. Done. Okay, so now we include all the 50 cases, sensitivity of gas liquid ratio, and the diluent rate percent. It's like this, but the most useful plot finish is sensitivity plot. So click this one. So it's pressure, salt diluent rate, change the variables to liquid rate. Okay, and x-axis variable GLR, gas liquid ratio injected. Click done. So it's optimization plot. Horizontal axis is gas liquid rate injected, gas liquid ratio injected. Vertical axis is liquid rate. And this one we have 5 cases of salt diluent percent. So now we will find which case will give us the highest liquid rate, or you can also change the variables to oil rate. Click done. So this one, the most important thing is I want to get the highest oil rate. And based on this optimization plot, it says that the best gas liquid ratio is around 800 here. around 800, or maybe this one. Okay, that's the best gas liquid ratio, and the best salt diluent percent is this one, this plot. So it is 20%. So it means the best configuration is to inject your gas with GLR of 850, maybe 850 standard cubic feet per stock tank barrel, and diluent rate percent of 20%. That will give you the highest oil rate and with dilute fluid. And with that, I conclude my 3 cases. So here we have learned 3 cases in Prosper. The first one is hydraulic fracturing. The second one is natural flow. The third one is gas lift with diluent injection. Okay, so that's all. I hope everything that we learned here is useful and we can have Q&A session.